I'm Induja, pursuing my final year MCA in Wheeltech High Tech Engineering College. My project title is NLP-based Relational Keyword Search Technique. The meaning of NLP is Natural Language Processing. This is the main objective of my project. In my project, I'm using natural language processing as a tool, and the system also focuses on data warehousing, which uses stop-word removal and stemming algorithm, as well as data mining, which uses n-gram algorithm. Annotation-based search technique is used to increase search timings. This is my company profile. This Janus Technology, where I'm doing my project. This is my existing system. In my existing system, the large number of approaches have been proposed and implemented. But in the existing system, the relational data has been an active area of research within the database and information retrieval community. This lack of standardization has resulted in contradicted results. These are some of the disadvantages of existing system. Keyword search was without the ranking based. So because of the unranking, execution time was more and lack of standardization was available. This is my proposed system. In my proposed system, I'm using the NLP tool, which exposes the relationship between execution time and factor varied in previous evaluation. So the memory consumption was very high. So even the small amount of data set is being stored in the form of vertices, and the result in indicating the existing system technique do not accept stable performance for realistic retrieval task. And in my proposed system, it's a semantic approach. Semantic approach is flexible to the end user, and it can add extra details by using the NLP tool. Your user can add the necessary words as the end user needs. And the previous system, it was systematic approach. The systematic approach was fixed, and the end user cannot add any details, and it is unpredictable. Words can be accurate. These are some of the advantages of my proposed system. Keyword search with the NLP tool. Execution time consumption is less. File length and execution time can be seen, and fast and accurate searching process was available with the help of the annotation process. This is the system specification. These are the hardware and software which I'm using in my project. This is a literacy survey. These are the algorithms which I'm using in my project. That is stop-word removal and a stemming algorithm for data mining, data warehousing, and n-gram algorithm for data mining, and a tool which I'm using is natural language processing. These are some of the models in my project. That is HTML and document parsing. And term pre-processing, table query based annotators, n-gram schema value, and NLP based. This is the first model, that's HTML and document parsing. It passes terms from input website. In this process, the HTML page is downloaded and it stores HTML document into that document is split into the pieces according to the tags and are grouped then with the values of each tag. HTML parsing is a filtering of data contents, dividing the HTML into the composed parts in a fixed parts. So both the semi-structured and structured data can be used in this HTML and document parsing. This is a model diagram of my HTML and document parsing. HTML parsing, download website, and the extracting of content and saving it as a HTML document. This is a screenshot of my HTML and document parsing. This is a second module, term pre-processing. In this term pre-processing, I'm using both the algorithms, the stemming and stop-word algorithm. Stemming algorithm will be removing all the prefix and suffix, and stop-word removal algorithm will be removing all the non-meaningful words like a and all that words will be removed. This is the overall model diagram of my second model. This is a screenshot of my second model. And this is my third module, table query based annotator. Under the third module, first module is table annotator. The table annotator can transform the database schema into an easy readable form. The Word document. The program can be present in the following information, like primary keys, key information, indexes, checks, constraints. All the tables will be a constructor in the table annotator. This is a screenshot of my table annotator. This under the third module, second submodule is query based annotator, where the text retrieval consists of using textual annotations. So all the images and all that extra fields will be stored over here. And this is a query-based annotated screenshot. This is overall model diagram of my third model, table annotator, retrieving of individual tags from the HTML document, grouping the similar tags, and query annotator calculating the similar tags and grouping the query according to the similarities. This is my model 4, Ngram. Ngram, under the Ngram, there are 3 sub-modules. Ngram indexing, Ngram pre-processing, Ngram extraction. Ngram indexing is, it will be indexed according to the search query. Ngram pre-processing is sequence of n terms which can be in, sometimes ngrams are not shared by text units. Or it can be shared as a sentence and paragraphs also. Ngram extraction is, it will be removing all the duplicate ngrams. Over the ngram means it will be efficient way of searching is an ngram process. This is a model diagram. Ngram indexing, building, and it will be a number of building sets according to the number of words. Ngram extraction, extracting sets URL. This fifth model, schema value and frequency based common value. Under the fifth model, first model is schema value. Schema value will help the instructor annotate how about the words which is being included in the span. And for example, the attribute professional may have a set of predefined values. Likewise, for each and every user, they'll be having a predefined values. Otherwise, they can also search for the other terms also with the help of the schema values. The schema values will be given from values will be from 1 to 9 only. The values will be given. This schema is screenshot. And this is a frequency based annotator. Under the fifth model, second sub model is frequency based annotator. It's a well-known factor for our audience. The frequency of words which is being used in each and every document, all that clearly will be shown in the frequency-based annotator. This is a screenshot. And then in the above box, it will be showing all the group members and the values which is all the group members with the search frequency of words they have been searching. This third sub-module or fifth module, it's a self-explanatory. All the available stocks and available stocks in the e-commerce sites, all those it will be known to the user itself. It will be, however, all the regular terms which we are using in the day-to-day life. This overall architecture diagram, model diagram. Schema value grouping with data and frequency-based group data according to the number of occurrence. All that will be given in this model diagram. This is my last module, NLP-based system model. This NLP tool is very useful to check a word with spelling and grammatical error. This is a model diagram of NLP. NLP process determines the relationship between the table, join expression for analyzing the database and displays the results. This is a screenshot. It will be displaying in a graphical format. Then if you want in another format also we can display, but in my project I'm using it as a graphical format only. This overall architecture diagram of my project. First, end user has to register, then only they can log in. After login, there will be HTML passing will be done. After HTML passing, tag filtering, then the stopword removal and stopword and stemming process, table annotators, and the schema value, frequency based, common knowledge, searching of terms, ngram extraction, NLP relationship, query based, schema values, and search results will be displayed to the end user. This is a use case diagram. This is a class diagram. This is a sequence diagram. This is a collaboration diagram. This is activity diagram. This is a DFT diagram of my project. Under the DFT diagram, this is a level 1. The user has to facilitate document annotation process to the admin. This is a second level 2. This is fully of user model only. User after registration, all that validation process, all that search term, it will be carried out by the level 2. Level 3 is fully of administration process, creating annotation, creating web page, reviewing of user details, detailed users, all that process, admin details will be catered by the level 3. This is a screenshot. This is a home page of my project. This is a new registration page. This is a validation checking. If the user password is not matching, all the validation checking will be done. In this validation, 2 types of testing is being done. That is unit testing and integration testing has been done in this validation checking. This is a user search page. This is my conclusion of my project. Hence, we favor a realistic query overload workload instead of a large workload with queries. This system uses natural language processing to find the relationship between keywords, which can be able to find some distant relationship. In my project, I'm using my data warehousing. Under the data warehousing, the stopper removal and stemming algorithm is being used, and in data mining, n-gram algorithm is being used. This approach decreases search time and produces accurate result by using the relation keyword search. These are the bibliography, some of the books which I'm referred for my project. These are the references which I'm using for my project. Now I'm going to run my project and show to you. This is my source code. I'm using my ASP.NET for developing this. The ASP.NET is very much, and after developing this project has been done in the internet with the help of the internet facility only. I'm running my project. After running my project, this new user sign up page, that is login page. If user is a new user, they are supposed to register. This is a new registration page. Here the validation and unit testing has been done. After registration successful, pop-up menu came. So we are going to log in with the username and password. This is a new username and password which I created now. We want to log in. This is a user search page. Now we are supposed to click this annotation tab, and this screen will be appearing. For anything if we want to search, we can give us a term. For example, I'm giving as wikis I'm giving. I'm searching this term, and I search as wiki, and this is a site which I searched. I have to need to copy this URL and paste it over here. And this is HTML passing which has been done, and this is a stop word removal, and this is stemming algorithm, and all the tags has been passed. According to the sessions, it has been passed. And again, we need to give this as a wiki here. You have to search. All the stemming and stop word and HTML passing is an internal process for demonstration purpose. It's a stimulation purpose and showing all this thing. But this is an actual searching process. The related sites has been displayed over here, and this is a resultant page, and this is schema values. Schema values. The schema values has been given, and frequency of all the terms. Frequency of search terms has been given. Under this, this is a site which we searched. If we click that page, this tab will be opened. And if the site is relevant to us, we are supposed to click how much it's relevant to us. This page which we search, that page will be displayed over here. This 10% relevant for my search. I have to give yes. And this group, we have created a linked list group, and these are the users who have searched that SBS Rajan into all these members have searched these terms. Then we have to go back, and again we are supposed to give us wikis. It will be displaying the search results, right? Then last process, that is annotation process, will be shown here. If we click show annotation, this annotation page will be displaying. Here you're supposed to, if we want this in a graphical format, you are supposed to click this show. This query annotation and the queries and list is being displayed. It's in a graphical format, and this annotation wrapper, this overall graph, and all the queries and terms which we have searched, and all the others have searched in the linked list group. It's been shown here. This is the last module of my project. I'm logging out of my project. And it will be displaying the user page again. If any user wants that, you can use it. Thank you.